All right, so just as a reminder, this lecture period we normally would not have in a normal semester, but we canceled fall break, and so we have the period available for us to use. So rather than me loading it up with a lecture from later in the semester, I'm keeping the lecture schedule kind of as planned. And today I'm happy to sort of treat this as a study session where we can work through some problems. A lot of people say, can we get numerical examples of solving for deadweight loss with a negative externality? Well, we can do that actually plugging in numbers, you know, like here's a formula for marginal benefit, here's a formula for this, formula for that, and we can sort of do that here today. And so I'm happy to do that. I can either come up with some things or take your questions. Other announcement type things. So just a reminder, homework C6 is due soon. I actually meant to look up the due date before I started, but I forgot to do so. But that's on Canvas, but it's coming up. It might even be this Sunday. Homework C6 does require you to do, I think, a negative externality calculation. So that would be valuable there. The other thing is that the midterm will be in basically a week and a half. And so that's, I think, on the 22nd. I think that's right, a Thursday. So, you know, that also is probably going to require you to do some of these calculations. Midterm will be on Canvas. So the way that will work is that you'll have to use Respondus Lockdown Browser. There's that compliance check thing that hopefully most of you have done. I'll go and see who's done it and remind people who haven't. And you do the compliance check, and that will unleash all of the midterm resources, including the midterms, the previous midterms, and the current midterm that you'll end up taking. And then on Thursday, on the 22nd, at 12 a.m. Thursday morning Arizona time, the midterm will become available, and you have to start it using Lockdown Browser with Monitor, and then you'll get 90 minutes to work through it. And so you can start it whenever you want during that day. There will be no lecture that day, so you could do it during the lecture period if you'd like. And you get 90 minutes. The reason I did 90 and not 75 is to account for any technical difficulties that might occur. Then you'll finish that. I think you'll get your score immediately, but then you can review your answers and the solution set the next day, that Friday morning sometime. Those will become automatically available. And then we'll do a retake exam that is, I forget when, it's like a week and a half after that. So you'll have the solutions, you'll know how you did, and if you'd like, you can come back and take the retake, and we'll take the best of the two scores. If you would prefer, you can just not take the first midterm and only take the retake. Just know that the retake is not the same test as the original one. So basically, when I design the tests, I put two Word documents next to each other, and I design question one here, and I design a question for the retake that is meant to be similar in content, similar in difficulty, but a different question. So it won't just be necessarily changing of numbers. It might be that, this question asks about a negative externality and this one asks about calculating for a positive externality. But so they're meant to be similar in scope and in difficulty, but different questions. And so there'll be the similar length. So all of that, but it'll be definitely a different test. And then, yeah, you can use I call it a formula sheet, but really I mean any type of handwritten or hand-typed notes. When you show your formula sheet to the camera, which I'll review, I don't want to see anything that's been copy and pasted from other resources. It can be typed. If you want to use Quizlet or something like that, that's also a possibility. I know some people are just more comfortable reading their typed stuff, that's fine. But I really want you to go through the manual effort of typing it all in or writing it all out and not just copying and pasting from like graphs out of the book or something like that. Most of the graphs that we get are pretty easy to hand draw. And so you could hand draw those and include images of those, for example. That's fine with me. Or just hand draw them on your physical paper sheet. But it just needs to look like it's been manually produced. And I think I say you can get one formula sheet that is two sides, or two formula sheets that's one side. And then I think I also say that you can get two initially blank sheets of scratch paper that you're free to use, and you're going to show all of those sheets to the camera as you start. And I'll double check that, but I'm almost 100% positive that that's what I did for this class, is one double-sided formula sheet and two blank sheets of scratch paper. And I call them formula sheets, but there's note sheets. So any other questions about that? Okay, great. I also have been told to update you about the final exam plans. So we've got this weird innovation quarter that cannibalized normal finals week. So we're not allowed to give you any final examinations or any assessments during finals week. We have to do it during the last week of classes, which has kind of become a combined class week and finals week. So I'd like to do this retake thing, but I don't really want to put 2 exams in 1 week. So what my plan is, and this is the first time I've ever done this, is to try what's called a 2-stage exam. So what that would mean is that, so Tuesday of the last week of classes, we do a final exam review session. And then Thursday of the last week of classes, you get an individual online Respondus lockdown browser plus monitor exam, just like the midterm, all configured to fit within 75 minutes, but I'll give you 90 minutes, just like on the midterm. And that'll all be Thursday. So the Thursday of finals week will be like identical to the midterm setup. But then instead of giving you a retake during finals week that I normally did, then what I'm gonna do, this is my plan, unless people bring up issues with this plan that I haven't thought of right now, and by people I mean like you, the students, unless you notice an issue with this, is the plan then is then to release the exact same test on Friday of that last week of class, the exact same test, but not require you to use Respondus Lockdown Browser. And that test will be a collaborative version where you can work with other members of the class, and you can also have all of the notes and resources that you have available that you've taken or that are available on Canvas. You can't go out and use Chegg or Course Hero or any of those things, but you can collaborate with each other and you can use the notes on each other. The Thursday individual test that you had to do on your own with a single formula sheet will be 80% of your final exam grade. And the Friday collaborative second stage, where you're just retaking the exact same test, but you're taking it with your peers or with your other resources, will be 20% of your grade. And so that's my way of not giving you, 2 exams, a pre-take and a retake within a very short period of each other, but still giving you the opportunity to kind of have a do-over for at least some of that. So 20%, is this kind of collaborative score, and 80% is the individual score. Again, it's the first time I've done a 2-stage exam. I'm going to give it a shot, see how it works out, and I think this is a great opportunity, this weird last week of classes, to do so. So that's the plan. If you think of any issues with that plan, please let me know. Just send me an email and I can adjust, but that, at least for now, is my tentative plan. All right, so any other questions about announcements or the schedule moving forward? If not, I can switch over, and maybe I will switch over as you're thinking of any questions to the kind of whiteboard side of things.
Sorry, so just to clarify, the first part of the final exam is Thursday, December 3rd, and then the second part would be the day after, Friday, December 4th, or is it the Tuesday and the Thursday?
No, the first one, Thursday and Friday. Okay. The Tuesday we're going to use as a final exam review.
Okay, perfect. Thank you.
Mm-hmm. And so at first it might say, oh man, I'm going to have to, these 2 days. But again, the Friday exam is exactly the same as your Thursday exam. And you have, and it's not time limited either. You just have the whole 24-hour period. You just can come back to it. You can come to it in the morning. You can work on it. Say, I don't really get question 10. You can go and email somebody and say, what do you think about question 10? You can go into Slack. You all can be using Slack together and monitoring that and look back through the history and see, does anybody else have an answer about question 10? And then so the hope is then you can help each other, with question 10. So then later at 4 p.m. that day, you go back and you answer question 10. And then when you finally feel happy with that, you hit submit. But you can also go back and I'm not going to force, I'm going to allow you to do resubmissions as well. And so you can go back and it will take the highest of those resubmissions. So you can utilize the entire 24-hour period to redo the exam that you did on your own in 90 minutes the day before. Okay. All right, so with that, I will stop that share and switch over to this share. Okay, I think that's up. Great. All right, so is there anything in particular that people would like to work out right now? Are there any, or would you just like me to start and like do a negative externality with formulas and then see if any questions are generated? And then I could do a positive externality like a public goods problem. No? All right, so let's, yeah, go ahead. I hear a mic. No?
Oh, I was just
All
going to
right.
say, yeah, can you go ahead and start with that?
Yeah, excellent. I can do that. So let's model the negative externality case. And so just for context, this is often viewed sort of for incomplete markets. You can imagine that this is for unregulated emissions. So this is like, imagine, modeling unregulated emissions in industrial production. So I am just going to make up numbers here, and we're just going to see how it lands. So I'm going to draw this market axis here. Where this is our quantity axis, and this is our marginal axis, dollars per quantity. And I'm going to say that, let's assume that we've got a good that has a certain marginal benefit. And so we're going to say that the demand is equal to the marginal benefit. And then I can give you a formula for this. And I can say that, and I do lines for this, just so you know, for those of you, if you ever, go on and do any more with kind of economics or sustainability, it does get harder and you start doing more general shapes. But all of the concepts work the same with lines. And so we generally use linear supply and demand curves. But in principle, they don't have to be lines. They could be, curvy or shapes and things like that. But it's just that all the same stuff works with lines, and so we use lines. And so I'll say that this has got, let me look at my axis here and count how many ticks to try to make this convenient. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so I'll call this 9 up here, 8. So you get the idea. And I'm going to say that my demand curve, let's say, is 9 minus 1.5 Q. All right, so that's the demand curves I know that I'm eventually going to have to draw, so I may as well draw that now. So I'm going to then say, all right, we start at 9 up here, and this 1.5 Q, that's equivalent to saying that it's got a rise over run where it falls 15 for every 10, or another way to view that is it falls 1.5 for every 1 that you run. So if this is what I'm calling 1, 3, 4, 5, 6, 7, 8, 9, 10, then I'm going to say, well, if I run 1, I'm going to fall 1.5. If I run 2, I'll fall another 1.5, and so I end up falling 3 for every 2. So that means that I'll be at 6, and then I run another 2, and I'll go down 3, run another 2, I'll go down 3. So it looks like I hit this axis down here at 6, and I can then connect all of those like so, and that is my demand curve, which in this case, we're just assuming is equal to the marginal benefit curve, which again is 9 minus 1.5 Q. All right, So that's kind of the review stuff of how to draw those. Are there any questions before I move on about, okay, I don't see how you drew that, or how did you get from 9 minus 1.5q to that line? Does all that make kind of enough sense so far? Yeah, that's
Yeah,
just none of them.
I just
Yep,
want to make
go.
sure that like if we're making graphs and stuff and using rulers and straight lines, like we're able to use our graphing calculators to make graphs like this, right?
Yeah, so I don't have any, the only restriction I have for like midterm for graphing calculator use would be that I don't want to see you on the video kind of scrolling through a graphing calculator in a way that suggests that you've got additional reference material on there that goes beyond your note sheets. But yeah, if it helps you to graph these things out this way, that's fine. For me, I'm just kind of drawing them as like if I was doing this on my own, I probably wouldn't necessarily be so clean about the straight lines, because all I really want to see is roughly the shape of where things intersect. And so I could kind of, fudge that and still kind of figure out where the triangles are going to be. So if it helps you to graph them, not by hand, but on your calculator, and you can still end up figuring out where all the points are for the midterm, that's totally fine. For the homework, the only downside of that is if you get the wrong answer, it may be harder for the TA, Moksha, who may or may not be here, to give you partial credit. So generally, I've told the TA that when she's grading the homeworks, if you get the right answer and you didn't show work, and if I didn't ask you to show work, then if the rubric just gives you points for getting the right answer, you're fine. But if you get the wrong answer and you've shown some work, that gives her an opportunity to give you partial credit. So
Yeah.
that's the only kind of red flag.
Yeah. What I mainly do, I only use my graphing calculator to like just like normal simple math or making graphs. Like all the work I do is still on paper itself.
Okay, great. Yeah, I think you'll be fine with that then.
Got it.
Okay. So that's our demand curve, but what really makes this exciting, this negative externality, is of course the supply curve and the marginal cost curves and how they all interact. And so I would say that for this particular industry, whatever industry it might be, we might have a private marginal cost curve. And I will just say, and again, just to make this kind of different, because I haven't done what we call an affine cost curve yet, I'm going to say is 1 plus, and maybe I'll do 0.5 Q. And so that would be a line that starts at 1 here. And this tells me that for every 1 we go over, we rise a half. So for every 2 we go over, we rise 1. So so this is, I can just say that for every 2 we go over, we rise 1. So I can know that this is, all right, so over 2, over 2, 2, over 2. So that right there. I will draw a clean line through there. And then that ends up being our private marginal cost curve, which for a for an incomplete market, that is the supply curve. So that also happens to be our supply curve. So knowing that the private marginal cost curve is the supply curve is one of the tricks of this problem. So make sure you know that. And so that tells us that in our unregulated market, then the market equilibrium is going to be right here. And so because I've drawn these out, it kind of gives me the impression that this is going to be the market equilibrium, QM, and this is going to be the market equilibrium price. In order for me to double check that, I'm pretty sure that's what it's going to be, but to double check that, I need to set those equal to each other. So you could say that at the market equilibrium quantity of goods that are exchanged, then supply is equal to demand. And so I'm just going to set those two things equal to each other. So supply is the 1 plus 0.5 Q, and the demand is equal to 9 minus 1.5 Q. And I guess I should make this QM just to show that I'm solving for the market equilibrium. And just as an interpretation, I've made this supply curve start at a non-zero value, and what that basically means is that the very first unit of good, that what it's sort of suggesting is even when we have 0 units of the good being in production, that somehow there's still a cost to that. So you could view that as the cost to keep the lights on or something like that. So that's why maybe it may not start exactly at 0; it's starting at 1. So just know that in general, even though these are lines, they don't always have to be lines starting from 0. But otherwise, the math works out about the same. So I set my supply equal to my demand. And so I can then, let's just say I'll bring the 1.5 QM over. So I'll do every step. So this becomes 1 plus 2 QM is equal to 9. And that's because I added 1.5 QM to both sides. And so adding that to that gave me the 2. And then I can subtract 1 from both sides, so that 9 will become an 8. So then 2 QM is equal to 8. And then that tells me then that QM is equal to 4. And that's what my graph predicted, because I happened to draw these nice straight lines that were, pretty accurate. And so then my question then is, what is the market equilibrium price? Well, I can plug that into either the supply or the demand curve. So I'm just going to say that my market equilibrium price is going to be equal to, in this case, I'll plug it into my supply curve. And so it'll be 1 plus 0.5 QM. And so that is equal to 1 plus 0.5 times 4. And so that is equal to 1 plus 2, which is equal to 3. And that is exactly what we got over here as well. So we now know for sure what that point is. So if this was a complete market, we would have just solved for not only the market equilibrium, but the socially efficient solution. But this is not. There is marginal damage here. And so I would also then give you a marginal damage curve, which maybe I'll put in gray. And so the marginal damage curve represents the additional damage done to society from the unregulated emissions. So the unregulated emissions are going up into the air, and they're not necessarily hurting the producer directly. They are a little bit, but they are hurting a lot of other people. And we can model that marginal damage curve. And I can say, well, let's say the marginal damage curve was, we'll say 0.25 Q. Which this would be equal to rising 1 for every run of 4. And so I can then plot the marginal damage curve as I go over. I'm going to start at the origin here, and every time I go over 4, I'll go up 1, 4, 1, 4, 1. So I'm going to put little dots there, 4, 1. And I go over 4, go up 1. Go over 4, go up 1. And so I can connect those. And so that there is my marginal damage curve. And so that additional marginal damage needs to be added to the private marginal cost to find the societal marginal cost, to find the total cost to society, which is the combination of the cost to the producer and the cost to everybody else. And so to figure out our societal marginal cost, maybe I'll do that in dark green. The societal marginal cost is equal to the private marginal cost plus the marginal damage. So the PMC is 1 plus 0.5 Q, and the marginal damage is 0.25 Q. If I simplify that, it's 1 plus 0.75 Q. And this 0.75, we can view that as rising 3 for every run of 4. So, and it starts over here at 1. So that is going to start over here, just like the private marginal cost. And every 4, so every 4 that I go over, it's going to rise up 3. Every 4 that it goes over, rise up another 3, and so on. So I can say, all right, every 4 it goes up 3, that puts a dot here. Every 4 it goes up 3, I put a dot here. Then I can connect those like that. And that there is the societal marginal cost, which is equal to the PMC plus the MD. And graphically, that should basically look like this line added on top of this line. I'm sorry, this line added on top of this line, which causes, so you can think of this little bit of damage here being added on top of this damage. So this is the producer's, this strand here is the damage to society. This is the producer's damage. We take that thing, we add it up here, and then we end up getting the total cost right there. So we've done that at every single point, and that's what gives us this green line here. So now we have to figure out what the efficient equilibrium would be. What would be the right allocation of these goods that properly would balance marginal benefits and marginal costs? And so the marginal benefits are this line here, and the societal marginal costs are this line. So we're looking for this intersection right here. So I need to set this expression for the marginal benefit equal to this expression for the societal marginal cost. So just in case you can see that again, this expression up here to this expression down here. You need to set those two things equal to each other to find the socially efficient. So run out a little bit of room here, but I am going to try my best to keep it on one page just to prevent from shifting back and forth. So I'm going to put, maybe I'll put this in dark green, 9 minus 1.5q is equal to 1 plus 1.75q. And I'm going to actually make this q star to make it clear that I'm solving for the efficient level. And so what I can do is I can move the 1.5q to the other side. I'm just going to add it to both sides. And I can move the 1 to this side, subtract it from both sides. So if I do both of those things, and I'm sorry that I do those simultaneously, but I'm just trying to save a little bit of space here, then if I do my math correctly, and I just want to, I'm going to manually do the math here just because I never do math correctly when I'm being watched, then I get that 8 is equal to 3.25 q star, where q star is the socially efficient quantity of this good that's exchanged. Then I can then divide 8 by 3.25. So 8 divided by 3.25. So I'll write that to make it clear here. Q star is then equal to 8 divided by 3.25, which is approximately equal, so I'm going to do some rounding, to 2.46, or roughly 2.5. And so looking at this graph here, it makes me think that I might have done something wrong, because the socially efficient equilibrium should hit right here. So I was expecting a number that would actually be in the 3 range. So so let's look back and see what I might have done wrong here. Yeah, go ahead.
Yeah, so your SMC equation is 1 plus 0.75 q, but you used 1 plus 1.75 q star. I think that might be why.
Thank you. That's absolutely great. This is why you guys are here. So I'm going to erase this stuff here, and I'm sorry that I wasn't looking up at the chat, but yeah, you pointed that out. So this down here, I had a transcription error where this should have been 1.075. But it was a teachable moment. I knew from this that the answer I should get should be around 3.5, because that's where this thing is down here. And so if you were on an exam or something like that, and you noticed that the answer you're solving for was not coming out to where you'd expect it to be on the graph, then that indicates that maybe you should go back and check your math. And so that's exactly what just happened there. So, so let me see what happens when I do the math correctly here. I am going to, again, move the 1 over by subtracting it. I'm going to move the 1.5 over by adding it. And what I'll end up getting is 8 is equal to, if I do this correctly, 2.25 Q star. And then Q star is equal to 8 divided by 2.25. And if I do that, 8 divided by 2.25, I get 3.56. So it's approximately, so that's approximately equal to 3.56, which is definitely kind of what I was expecting. So that's my Q star. That's my socially efficient equilibrium allocation. And then what I want to do then is figure out what the corresponding socially efficient price is going to be, which I'm expecting to also be between 3 and 4. So I'm going to take this 3.56 and I can plug it in to either the demand curve or the social marginal cost curve. And I'll plug it into the social marginal cost curve. And so the price star is going to be equal to 1 plus 0.75 times 3.56, or this is my Q star. And so if I do that math, so 1 plus 0.75 times 3.56 gives me about 3.67. And so that right there is the P star. Okay, great. So let's see if there's any other intersections that we are going to care about. And this intersection right here is also going to be one that we care about. And this intersection down here is going to be one that we care about. So this intersection right here is going to allow us to calculate the producer surplus. And this intersection up here is going to allow us to calculate the deadweight loss. And so we need to solve for that one as well. And so in order for me to find this point right here, I just need to plug in QM into the SMC function. And so that SMC function is, where did I put the SMC? The total, oh, it's down here. So is this guy. So I'm going to plug in into my social marginal cost 1 plus 0.75 times 4. And so that point ends up being 4. And if I do that, you know, then that's one that's easy to do and ends up being 4. And that actually makes sense because you can see it lines up right here with 4. So that math looks good. So I've solved for that corner. And the last corner I need to worry about is this point right here, which is the private marginal cost evaluated at the socially equivalent, or the socially efficient equilibrium. And so the private marginal cost is 1 plus 0.5 Q. So this point right here is going to be Q star, which is 3.56, and 1 plus 0.5 times 3.56. That's this point right here, which is just 3.56 times, and then the y-axis is going to be 1 plus 0.5 times 3.56 is 2.78. And so that's that point right there. And just to, as a check, that does seem to be about right. That's about 2.78. So now I have all of the points needed to solve for anything that I could possibly ask you about this diagram. So I can ask for different areas and things. So let's say I want to know I can do some highlighting here. I might want to know, maybe I'll draw some dashed lines just to separate things out a bit. And this upper region.
Wait, I got a quick question.
Sure, go ahead.
I was lost for a second. Well, on the supply curve, what was the point of
Mhm.
those two equations, or those coordinates on the supply curve that you wrote down a second ago in the red?
This one here. So this point right here, we need to know that point in order for us to calculate these. So there's a, if we were to, oh, and I accidentally so this bottom portion here is the producer surplus at the efficient equilibrium. And in order for me to calculate the area of this trapezoid right here, I need to know that corner right there. And
Okay.
so that's, it gives me the height right there.
Okay.
So those are the regions that I care about. So let me highlight those regions. I started to highlight them kind of improperly there. So if I force the producer, and how you can say, what do you mean force the producer? So we'll get into that sort of towards after the midterm, but we're going to talk about one way in which we can force incomplete markets due to negative externalities to be complete markets is to tax the individuals at a rate which is in accordance with the marginal damage that's being done. So if I tax everyone in the market at this rate, where I basically charge them for every unit that you produce, I'm going to charge you this tax here. Then this marginal damage that has been being done to the rest of society will now be directly done to the producer. So the producer will have to incorporate the marginal damage into their supply curve. And so by doing that, I will shift the supply curve from here to here. And that's the way that's the one way out of a couple. That is one way that I can force producers to pay attention to the damage that they're doing to society and force them, the market, to naturally equilibrate at the socially efficient equilibrium. Now, if I did that, I would then want to calculate the producer surplus at this new price that incorporates not only their price of doing business, but also the cost that they're doing to society that I've now forced onto them, say, due to a tax. And so that new producer surplus is going to be this region down here. Remember, the producer surplus is the region from the agreed upon price in the market down to the actual cost that the producer feels. So this is due to tax, for example, so I forced them to pay additional cost, but the actual cost that they feel for the good is down here, and that's why the producer surplus is this trapezoid shape. And so I can calculate the producer surplus either by adding up the shape of this rectangle plus the area of this triangle, or I can be a little bit fancy and dig up an area for a trapezoid. And the area for the trapezoid is 1/2 times the height of the trapezoid, I'll call this the height, times the sum of the two bases, where this is one base and this is the other base. So I guess it's getting a little ugly, so maybe I have just accidentally turned off my screen as I was moving my tablet around. So let me reshare. I apologize for that. Share screen, start. Okay, so that should come back. There we go. So the producer surplus at the efficient equilibrium, so at Q star P star, is going to be equal to 1/2 times the height of the trapezoid, which is just this distance here, which if I drop down, I say that is equal to Q star. So it's 1/2 times Q star. So maybe I'll just write in Q star as a reminder, and then I'll put equals 3.56. I'm looking up at the chat to see if I missed anything. And then the two that we add in here, we add this height and this height. So this height over here, this long height, that's kind of an easy one. That's just going to be P star minus 1. So I'll put P star minus 1 is the first height, which is going to be equal to 2.67. And then I add in the second height, which is over here. And then that is going to be equal to P star minus PM. So that's P star minus PM, which in this case is going to be 3.67 minus 3, which is just 0.67. All right, so I've got 3.56 here. That tiny little, it's almost worthless for me to write that, so maybe it'll causes more confusion for me to write that in. This is just 3.56 times, and then I've got to have this sum. And so this is going to be the sum of 2.67 and 0.67. So if I add those together, 2.67 and 0.67, I get 3.34. So 3.34 represents this whole quantity. And then I'm going to multiply that 3.34 by 3.56, and then that by 1/2. And so that ends up giving me, so 3.34 times 2.6, I'm sorry, 3.56 times 0.5 gives me 5.95. And so that is the producer surplus at the efficient equilibrium Q star. So then I might also then ask you for the consumer surplus, which is this triangle up here. And so the consumer surplus at Q star is just going to be equal to 1/2 base times height of this triangle. And so if I look at this triangle, I'll call this base. Well, that is just equal to Q star. And the height is equal to 9 minus P star. So that's 1/2 times Q star, which is 3.67. And then that whole thing times 9 minus P star. So I did that. I apologize, that Q star is not the right Q star. This base is supposed to be Q star, which is 3.56. And then the other part of it is 9 minus P star, which is 9 minus 3.67, which is 5.33. And then if I multiply all that together, I've got 0.5 times 3.56 times 5.33 is 9.49. And so now I know the two of those together end up being kind of the net benefit to society by operating at the socially equivalent equilibrium. The two other quantities that I might then ask you for, and maybe before I do that, are there any questions about those? Calculating the consumer surplus and the producer surplus for at the socially efficient equilibrium. Okay. So I might also then ask you for this tiny little triangle down here, which is the lost producer surplus and consumer surplus at the efficient equilibrium. And that isn't, again, going to be just a 1/2 base times height type of deal. And so that, I might move that into in this other region just to give myself a little room. So maybe I'll put that. Let's get rid of the arrow. And I'll redraw that arrow. And so that is going to be equal to 1/2 base times height. And so this is a little tricky. I've been noticing the people who've turned in the homework already that some people have been trying to do some like fancy trigonometry to figure out like the legs of all these things. Turns out it's much simpler than it looks. All you really need to know is this height, which we actually already calculated for a different calculation, and this, or if you call this the base perhaps, and then this the height. So I don't actually need to know the length of either one of these legs of the triangle. All I need to know is how high the triangle is, the kind of perpendicular distance from the base all the way up to this apex of the triangle. And so the base here is just going to be equal to P star minus PM, which we already did down here, P star minus PM. Right here, P star minus PM, that was already done right there. So that's 0.67, so I can do 1/2 times 0.67. And then the height of this thing is just going to be equal to QM minus Q star. So this here is the height, QM minus Q star. So it's going to be 4 minus Q star, where Q star is 3.56. So I can write that in here. It's just 4 minus 3.56. And so those things together, 0.5 times 0.67 times 4 minus 3.56 gives me 0.15. It's approximately 0.15. So that's what goes in there. And then the last thing that I might ask you to calculate, maybe I'll use a lighter shade, is the deadweight loss, which is this right here. And this is something I know from the muddiest points. Deadweight loss is still a little confusing, but if you think about what this deadweight loss is, it's just if you were to operate at the market equilibrium, the unregulated market equilibrium without the tax, then you would not only be getting, you would be getting marginal benefits that would be down here, but your marginal cost to society would be up there. So because your marginal costs are greater than your marginal benefits, then that accumulates into reducing your total benefit. So basically the area of this triangle represents how much reduction you're getting of your total benefit just by operating, by overproducing, because you're producing too much emissions, too much pollution, too much marginal damage, to the point where your marginal damage is growing faster than your benefits are growing. And so the net effect is that your social welfare is going down. And this is representing, the deadweight loss is representing the damage to your social welfare by overproduction. And so this triangle is just going to be 1/2, is just going to be equal to 1/2 times its base times height. And so we actually know it's this dimension already. We already calculated that. That's just the 4 minus 3.56. So I can put that in. That's kind of this dimension. And then I need to know the other dimension here And that's finally where we're going to make use of this 4. That's going to be equal to 4, which is this upper point, minus this point here, which corresponds to the market, yeah, that corresponds to the market price. And so you can think of that as the kind of vertical dimension of this triangle. So if I calculate out that deadweight loss, I've got 0.5 times 4 minus 3.56 times 4 minus 3 gives me 0.22. And as expected, the deadweight loss due to overproduction is greater than the lost producer and consumer surplus due to operating at the socially efficient equilibrium. So what that tells me is that it is a Kaldor-Hicks improvement to shift from producing this much to producing this much, because by moving down that way, you are going to reduce some of the producer and consumer surplus, but you're also going to reduce the costs that are being paid due to the emissions by an even greater amount. So you get a net benefit by actually moving to less production. So that is what we're kind of capturing with this diagram right here. And so those, I think, are all the quantities that I would ask you for if we were to do one of these negative externality cases. So are there any questions about those?
Can you repeat what you just said about like how this is a Kaldor-Hicks improvement where deadweight loss is greater than the quantity of lost producer surplus and consumer surplus? Like, how do you find that out?
So right, so what I'm saying here is if I compare the deadweight loss here to the lost producer consumers and the lost PS plus the CS, then what I find is that the deadweight loss is greater than the lost PS and CS at Q star. So this is, I guess, the deadweight loss at QM. So if you were arguing, you know, what production, where should we produce? Should we produce, what's best? Should we be producing 4 units of the good, or should we, 4 million units of the good, whatever, or should we produce in Q star, which is 3.56 million units of the good? And so you could say, well, on one hand, if we produce 4 units of the good, then we are going to gain this amount of producer and consumer surplus. We're going to gain this many dollars, so $150,000. But what this tells us is that by operating here, then you're also going to pick up this amount of deadweight loss, say $220,000 in deadweight loss. So by, even though producing the additional units is going to bring in more revenue, and it's going to bring in more revenue to the producers and more benefit to the consumers, the additional cost due to the air getting worse will actually be greater than those benefits. And so it's actually better to produce less of the good, because by producing less of the good, we have less pollution in the air. And the right balance is actually going to be at this point, not at this point. Does that help?
So essentially, if we were to add more, that lost PS in plus CS will add into the deadweight loss, which will make matters worse.
Well, so I want to be clear that this is the lost. This is viewed as the lost surplus when operating at the lower amount. So when you produce less, you're going to lose this amount here. You're going to lose this when you produce less.
Okay.
And so the question is, what's better? To lose the surplus and also lose the pollution, or to gain the surplus but also gain the pollution? And what this analysis suggests is that the pollution is actually worse than the lost surplus.
Okay. All right, got it. Thank you.
Okay. Any other questions about this negative externality case? Okay. All right, well then the other numerical example that you might be, so I'm going to flip to a new page. So this is going to be fresh. So if you have any questions about this, it's I'll post these notes online as well. But I'm about to flip to a fresh page. So any other questions would be a great time to bring them up now. All right, so now we can say, all right, what about the public good case? And so that is the case of a positive externality. And by the way, both of these cases, I actually, as I mentioned in the announcement, have made a separate video on just negative externalities and on just public goods positive externalities, where I work out yet another example, kind of like we just did here today. So if you need another example, look on Canvas at the bottom of Unit C, and you'll find some additional videos on this that you can skip through. And I've got the PDF that is associated with those videos as well, in case you just want to look at that. So that should give you another example. All right, so in the public goods case, let's draw that axis. And so this is a little simpler than the negative externality case. Actually, I'm going to draw that a little bigger just to give myself a little bit more freedom. And so quantity supplied, and then the marginal axis here. And so in this case, for a positive externality due to public goods, then I am going to assume that we have the supply curve is known, and it really does equal the total marginal cost to society. And I am going to make my supply curve, just for kicks, I'll make it the same supply curve as I did before. So that supply curve is, that private marginal cost is 1 plus 0.5Q, and I'll just do 1 plus 0.5Q again, just because I'm not feeling very creative. So that is going to start down here at 1, and then this 0.5 here just means for every 2 that I run, I rise only 1. So here I get a line that looks kind of like this. Nope, let me make that a little straighter. That's good. All right, so that's my supply curve. It's equal to my marginal cost. And now, because this is the public goods case, then we have 2 classes of consumers. We have consumers who are, we can call them, members. That's one way to view it. And they have a demand curve, which is equal to their own private marginal benefit. So I'll say the marginal benefit to the members. And I'm just going to say that's equal to 2, 3, 4, 5, 6, I don't know, we'll say 7 minus, and I don't know, we'll do 0.5Q again. And then we've also got a separate set of consumers that we'll call free riders. And they, if I were to say, what's their demand curve, their contribution to demand is equal to 0, but their marginal benefit is not 0. So I'll say their marginal benefit is, I don't know, we'll call it 2, we'll say 3 minus Q. Yeah, okay, I'll try that. I don't know, that's a little steep. Maybe I'll do 3 minus 0.25 Q. All right, so that's kind of the key difference between these 2 groups, is that one of them contributes to demand and the other one doesn't. And so the demand curve is just from the member group, and so I can plot them up here, 2, 3, 4, 5, 6, here's 7. And so, and then for every 2 that I go over, they drop 1. So I get a curve that is going to look like this one. And then my free riders, so I will say this here is the demand curve. Which happens to be equal to the marginal benefit for the members. But then my free riders, they don't contribute to demand, but I am going to plot their marginal benefit curve in it. So I'm actually keeping track of how much they're benefiting from the product that is effectively being provided for by the members, because the members are paying for the product, but both groups are getting the benefit out of it. And so I can plot their benefit down here at, it starts at 3. And every 4, it drops 1. So it looks like that. All right, so I've got these two curves here. I know that the market equilibrium is going to be where supply meets demand, which will be right here. That was a fail, right here. So I can solve for that. I can say, well, supply is equal to demand. I know that my supply curve is 1 plus 0.5 Q, and I know my demand curve is 7 minus 0.5 Q. I can take the constant terms and move them over. So let's actually, what I'll do is I'm going to take this 0.5 Q and add it to this 0.5 Q, and take this 1 and subtract it from that 7. So overall, I get Q, that's 0.5 plus 0.5, and I guess I should say this is Q market. So Q market is going to be equal to 6, if I did my math right there. So I just took the 0.5 here, added it to this 0.5, that gave me the 1. I took the 1, subtracted it from both sides, that gave me the 6. And if I did things right, then down here, if I count over, this is 1, so here's zeros. Here's 2, 3, 4, 5, and 6. And then lo and behold, yes, looks like I got that right this time. So then I need to calculate my market price. So the market price here, I can just evaluate the supply curve at that. So I'll do the supply curve, which is 1 plus 0.5 times QM, which is equal to 1 plus 0.5 times 6. So half of 6 is 3, so that price is equal to 4. So if I go over this way, it does turn out that that's equal to 4, as expected. All right, so that's the first point that I would be interested in. But so now the problem is that I would be, I'd be interested in you solving is to figure out what is the deadweight loss due to the fact that we've got members that are enjoying a benefit but not paying in. So they are not contributing to the demand, but they are enjoying a benefit. So at 6 units of this good, and you can say, what are these types of goods? And I can say this, I used public radio before, but pollution abatement might be more exciting to you if you're kind of thinking in terms of sustainability. So you can imagine this is quantity of abatement. And so the idea being is that there are people paying for this amount of abatement. There are others that could be paying for more abatement, for cleaner air, but they are not. They're just enjoying the cleaner air provided to them from the ones who are paying for it. And so they are currently enjoying it this much at this level. And so what I'd like to see is, all right, what's the total marginal benefit to society? And so I get that by adding these two things together. And so the marginal benefit to society, maybe I'll write that down here in green. The marginal benefit to society is the marginal benefit from both groups added together, the members and the free riders. So that's 7 minus 0.5 Q plus 3 minus 0.25 Q. And that gives me a 10 minus 0.75 Q. So I can plot that 8, 9, 10. And I may end up, let me move, I'm going to move this demand out of the way. Maybe I'll just erase it and rewrite it. So I'll just write down this way, demand equals marginal benefit members. And then if I go back and draw my total marginal benefit curve, which is above the demand, 10 plus minus 0.75 Q, if I then, this 0.75 means every time I run 4, I drop 3. So I'm going to put a point there, and I'm going to keep doing that. So I run 4, drop 3, that gives me here, run 4, drop 3, that's here. And then I would run 4, drop 3, and I hit here. And that is actually as far as I need to go, because after that point right there, then the marginal benefit of the free riders drops to 0. So they stop contributing. And so the rest of the marginal benefit curve for society just follows the members curve. So I will then draw that line in. So it's a straight line. That hits to there. And then it just kind of follows along this line here. All right, so that is my total marginal benefit. And by doing that, then I can see that if I was in an ideal world where everyone paid in, everyone contributed to demand, then this here would be the socially equivalent or socially efficient equilibrium. And that's where I take my total marginal benefit and I set it equal to supply. So if I set the marginal benefit equal to supply, then I get 10 minus 0.75 Q is equal to the supply, which is 1 plus 0.5 Q. So I'll take, that'll say 9, and I guess it'll be Q star. 9 is equal to the 0.75, I move it over, and so I believe that gives me a 1.25 Q star, which tells me that Q star is equal to 9 divided by 1.25, 7.2. Then that's what I got down here, 7.2. And then the P star is just going to be equal to the supply curve evaluated there. So that's 1 plus 0.5 times 7.2, which is equal to 4.6, which if I were to draw this over here, then I get my 4.6 is equal to P star. All right, so so then the only other point that I'm interested in here that I'll possibly need to calculate is this point up here, which represents the total marginal benefit that I'm getting at the market equilibrium of Q. So I'll maybe remind us that this is the market equilibrium. And so that point I can get by evaluating the total marginal benefit at 6. And so the total marginal benefit at 6, so the marginal benefit when Q is equal to 6 is just equal to 10 minus 0.75 times 6, which is equal to, yeah.
When you were measuring, wait, how'd you get a Q star being 7.2 when you were measuring MB?
So Q star, just drawing this up here, 5.5. The Q star being 7.2 here comes from setting this curve, which is the total MB curve, which is down here, setting that equal to the supply curve here. And so this here is me doing that. So I just forced MB to be equal to supply, and that is what gave me this intersection here. And so that's this expression here. Does that make sense?
Yeah.
All right. So I've now solved for all of the relevant points. So basically these 3 points are the really important ones here. And now I can calculate surpluses and deadweight losses. So what this tells me here is that at the efficient equilibrium, so let's look at the market equilibrium. At the market equilibrium, I can say what is the consumer and the producer surplus. At the market equilibrium, so that market equilibrium, and I'll just write that in again. Remember that PM, the price at the market, is equal to 4. And so the market equilibrium is going to be evaluated along this line here at 4, where consumer surplus is going to be a trapezoid. And then producer surplus is going to be the triangle underneath. And so that is the producer surplus at the market equilibrium, and this here is the consumer surplus at the market equilibrium. And because we're short on time, I'm not going to go through the calculations for those. Again, it's just the trapezoid calculation and the triangle calculation. And then the only thing left over then is saying, well, what's the deadweight loss? Well, what we're saying is that if we would actually produce as much as, if people who were paying, if everyone paid in according to the benefit that they're receiving, then we could actually fill out this region right here. And so this little triangle represents the deadweight loss for for operating at QM instead of Q star. And so you could calculate the area of that triangle. So for example, that would just be 1/2 times the height of the triangle, which is Q star minus QM. And then by height, I'm referring to this direction. So that's kind of the horizontal direction of the triangle. And then the vertical direction of the triangle, so I'm referring to this one here, is 5.5 minus PM. So that's 5.5 minus PM. And so I could end up calculating out what that deadweight loss is, and that would be there. So again, we're right here at 1:15, so I'm not going to go through with any of those calculations, but that's basically how you can set up one of these public goods cases where you've got this positive externality that has a group of free riders who don't contribute to demand and a group of members who do. So in the last couple of minutes, if that's all I've got for you, we're at regulation. I can't keep you any longer than that. If you have some questions, I can stick around for a few more minutes. And if not, you can feel free to head out. And all this, the video and these notes I'll put online as usual, but no attendance question today.
Okay, I got one last question, which is sort of a repetition from before. It's back to negative externality graph. Can you explain again of like what the conclusion is about operating the industrial operation of deadweight loss and lost PS plus CS. I was sort of lost again of how those both work.
Sure. Yeah, so we're saying that in an unregulated market, producers will, they'll just keep producing as much as possible until their private marginal cost is equal to the private marginal benefit. And so basically, as producers produce more, they will raise their prices, and so that and eventually you come to an equilibrium where the price that they can reach ends up being equivalent to the marginal benefit that people will feel, and you end up at the market equilibrium, which is right here. And so the producers here are actually setting a slightly lower price because they found that because it's a competitive market, otherwise it's competitive. So in order for producers to compete with other producers, they lower the prices to get more quantity here. And so, so we could tell a producer, you need to produce less. And in order for you to produce less, you need to charge more. One producer is not going to just charge more. They're going to say, well, but my competitors are going to charge less. And so the market equilibrium without regulation is going to be at a lower price, and that lower price is going to have a higher quantity of goods being put into the market. Now, that might sound like a good thing. More goods are being put into the market, and those goods are cheaper. So more people are getting access to the goods, and so that's got to be a good thing. But the downside is that at this market equilibrium, you've also picked up these costs that are not necessarily just accounted for by the price of the good itself. And so these additional pollution costs are what is captured by this gray area, this deadweight loss up here. So the additional benefit of lowering the price and increasing the quantity is captured in this orange area, but the additional cost of that maneuver is captured into this gray area. And because this gray area is larger than this orange area, then it's actually better to use a higher price, better for society to use a higher price. Now, how do we get producers in a competitive market to all agree on that higher price? Well, one way we can do it is tax them all. We can say across the board, if you're producing this good that produces these emissions, then we're going to tax you for every unit of those emissions, and that's going to make every producer in a competitive market raise their prices. And that increase in prices is going to reduce how much goods are available. By reducing the number of goods available, you reduce the pollution. And society will be better off, even though fewer goods are being produced.
Okay.
Does
All right.
that
Thank
help?
you. Yeah, that helps a lot. Thank you so much.
Mm-hmm. Any other questions from the other hangers
I
on?
have a question.
Yes.
Not to make you repeat yourself again, but the difference between the deadweight loss and the loss at consumer surplus and producer surplus at the socially efficient equilibrium, can you repeat that difference again?
Yeah, so the deadweight loss is, and I guess maybe I could just write this down, is that for the negative externality case, the deadweight loss is at the market equilibrium. So I could say at the market PM, so is it QM comma PM, and that is the additional cost due to marginal damage relative to the Q star P star case. And then the lost PS CS at QM, or at Q star P star, is the, you can view that as the additional surplus, both producer and consumer, relative to operating, or the additional surplus, sorry, not relative to, the additional surplus gained if moving from Q star to QM. So this here is what you gain by increasing production. And this here is what you lose by increasing production. And so this is due to pollution, and this down here is due to profits. And it will be the case that the deadweight loss will be greater than the lost producer and consumer surplus, which implies that you're actually better off using less pollution, even though it'll mean less profits.
Got you. That is so helpful. Thank you.
Sure. Any other questions? I think most everybody is headed out, but happy to take another or two. All right. So in that case, we'll see you Thursday for the next formal lecture. Have a good day, a good week.